Hello and welcome to today's Australian Water School webinar on advanced PFAS treatment technologies in practice. I'm your host, Cray Price, and I'm excited to be with you today and to introduce you to some expert presenters who are going to help expand our knowledge of this very important topic, very timely topic these days. Let's first welcome all of you, our attendees from all around the world. Thanks so much for attending today. We are going to make this as interactive as we can, so this will involve some audience participation from you. The Stormwater Treatment 101 course, so that's something for beginners, for those who are a little more advanced as well. We'll have a little bit for everybody there. These will be brought to you by the presenters that you see today. So with that, let's introduce you to today's presenters. We've got with us, if you can turn your cameras on, Brad, Blake, and Michael. Let's have you give us a quick introduction. Let us know where you're coming to us from today and how long you've been in the PFAS business. Brad, over to you first.
Yeah, so I'm Brad from Ocean Protect, Principal Environmental Engineer. We've been doing PFAS as a company for a little while, mainly in R&D phase, but we've got some pretty cool technologies, which we'll talk about in a sec. But I've been looking at PFAS for a while before Ocean Protect as a consultant, providing advice to some people battling some nasty litigation.
Excellent. Blake, over to you.
Thanks, Ray. I'm coming from Sydney. I've been looking at PFAS, particularly around the removal from stormwater for about the past 6 years, starting with my university thesis at the University of New South Wales, moving through a variety of laboratory and field studies.
Perfect. Michael.
You're on mute, model.
Like there it is. Back again, Brad. Look, good morning, everyone. I'm Mike Wick, CEO, Ocean Protect. Look, we've been involved in PFAS for the last 4 or 5 years. We deal in different types of media filters and part of the emerging contaminants division within the R&D department. We were looking at PFAS among other contaminants. So that sort of brought us all the way here, I guess.
Excellent. Well, let's find out a little bit about how much our audience knows today about PFAS. So if you have a look at that, they'll pop up on your screen. We can see that there are most people on this webinar today know only a little about PFAS. There are a few who have never even heard of the term, and there are just a few who know a lot. We have a couple of teasers for some of the content that'll be coming up during the presentation itself. Most people not aware of the study, but coming to you from Australia, maybe you would expect the platypus there to be coming right out on top, but we'll talk to that in a little bit. And it looks like we're not really aware of how much of this budget might be covered. It could be, these are orders of magnitude. So we'll get a little bit of an education about that today. Brad, any surprises in those poll results that you see?
No, not at all. It is a reasonably newish topic, albeit a chemical that's been around for nearly 100 years now. But the industry is grappling with it on a range of fronts. But yeah, I might give a sneaky peek. Some of those answers are very soon. Craig, if you like.
Excellent. Sounds good. So that was just a little bit of a teaser of what's coming up. So thanks so much to our webinar sponsor today, Ocean Protect. You'll see a couple of cool, innovative products that they'll highlight, but this is for the industry as a whole as well. And so we are looking forward to bringing this content to you, whether you're brand new to this subject and want to know what PFAS even stands for, or whether you're a little more advanced and are looking for actual applications to spec out to be able to help address this problem. So Brad, if you want to start sharing your screen, the rest of us will drop into the background. Looking forward to hearing your content. I can see your screen coming through just fine. So over to you.
And look, Blake's not allowed to hide in the background. He's presenting with me. So Mike can hang around doing the Q&A. But Blake, please turn your camera on. Show us how ridiculously good looking you are. But look, and some people don't know what PFAS is, so we're going to dive into some of the. I'm going to give a crash course in some of the fundamentals to bring everyone up to speed. But we did do a webinar on this with the Australian Water School called the PFAS problem. So I dive into that in a lot more detail in that webinar. So if you sort of if I go too quickly in some of these parts, just tune into that previous one, or alternatively just reach out and I can talk about PFAS till the cows come home. But yeah, what is it? It is a forever chemical. It's been around for a long time, like I mentioned. It's been around for about nearly 100 years now. And it's got some very, very unique properties that make it very useful in a bunch of products, whether it's the non-stick fry pans, waterproof clothing, or in firefighting foam. It's got some very unique properties that make it very useful for those uses. It's also got some pretty unusual chemical properties that don't make it too crash hot as well. It doesn't biodegrade, so it's a forever chemical, stays in the environment for a very, very long time. It's got a very, very strong carbon fluorine bond, which makes it, again, very strong and very unique. And it's very water soluble as well. So all those things, and often we're dealing with really, really low concentrations, which makes it very difficult to remove from a treatment perspective, which I'll talk about in a sec. What's all the fuss about? Yeah, it's got some problematic properties. It's identified as toxic. It bioaccumulates, so it as you move up the food chain, it basically gets to higher and higher concentrations. It absorbs to your fatty tissues, like your livers, etc. It's pretty much everywhere, which I'll touch on in a sec, and it is linked to a whole bunch of negative health impacts. So subsequently, it's a high priority for a bunch of environmental regulators, and I know a lot of them are actually on the call today, so welcome. And you would have seen it potentially in the media. So whether you're watching The Incredible Hulk, Mark Ruffalo, talk about suing manufacturers of PFAS, or concerned about it in your water supply, or finding it in pretty much everywhere, whether it be wildlife or ourselves, it's getting a lot of attention. And obviously, a lot of the media attention is around the lawsuits that some of these PFAS manufacturers are facing. And we're talking about billions of dollars as well. So a big issue. So touch on some of those media articles and scientific papers. Yeah, it's in our rain. So it's everywhere. Falls from the sky. We're not talking about stuff that we just, washes off our polluted areas. It's in our rainfall and snow. So subsequently, it's in a whole bunch of surface and groundwaters, sometimes at elevated concentrations. And before we get all doom and gloom and crying to our beer about the state of PFAS in the world, we need to recognize that PFAS is also in our beer. So a recent study in the US showed that, looked at a bunch of beer being produced in the US, and elevated levels of PFAS in those unfortunate beverages, probably almost certainly due to the source water being used in the beer processing facilities. And look, this isn't just a problem in say countries with laxy-daisy environmental standards. It is a massive problem in Australia, and the highest concentrations of PFAS in dolphins anywhere in the world is right off the coast of Southeast Australia, so adjacent to Melbourne and Port Phillip Bay, Gippsland, etc. And a recent study, and I saw a few people get this right. A recent study by the Western Sydney University, it was Catherine Warwick, looking at PFAS concentration in the livers of platypus. And a reason I talk about this is the platypus carcasses were actually from very regional areas, so not downstream of airports or firefighting facilities, pretty much fairly remote conditions, and elevated concentrations of PFAS in the liver. A, because PFAS is pretty much everywhere, and B, it does concentrate as you move up the food chain, and particularly attached to fatty tissues like livers. And a recent study put out last year by the Bureau of Statistics found that 98% plus of the Australian public have at least one type of PFAS in our blood, and over 85% of them, 85% of us in Australia have at least three types of PFAS in our blood. And the key thing to keep in mind in relation to PFAS is it's not just one or two or three or five or six chemicals. We're talking about thousands of chemicals. So they might, I think the last count was about 13 or 14,000 different types of PFAS, all with different properties, which obviously makes them even harder to achieve. So with different properties, they have different sort of, processes that need to be applied to remove them as well. But from a human health perspective, that elevated concentration or recorded concentrations in our blood and vital organs has been at least linked to a whole bunch of human health issues. Now, this might be up for debate. On one side of the debate, they'll say, it's nothing to worry about. On the other side of the debate, we'll be like, there's a lot of links to a range of health conditions, whether it be reproductive limitations, cancers, etc. And I think at the very least, we need to be applying a precautionary approach, which we obviously do in a lot of parts of the world. But yeah, so keep in mind there's a lot of money involved in this. So obviously the PFAS manufacturers of the world would probably propose that the health implications are pretty minor, but I think a very large and growing body of scientists are saying otherwise, and it's something that we really need to be concerned about. Is my water safe to drink? It depends on where you are, but at least in Australia, you can see the general advice is that, PFAS levels are generally below Australian drinking water guidelines. Having said that, we still see instances like the Medlow Dam in the Blue Mountains, which were shut down because of elevated PFAS concentrations. Now, keep in mind, Blue Mountains is a very pristine area in Australia, but even that area had recorded elevated PFAS concentrations. And in other parts of the world, I know we have a bunch dialing in from the States today. Yeah, I don't have to tell you guys, PFAS contamination is fairly widespread across the US and as similar to other countries. And the money involved is out of this world. So to give you an example, this is just one stakeholder, the Australian Department of Defence. They have spent, these figures are a little bit old, but the best publicly available I can get today. But yeah, they've spent already $850 million, just one stakeholder, $850 million on managing and remediating and researching PFAS. And just last financial year, they were planning to spend $165 million in one financial year around management and remediation of PFAS. So again, one stakeholder, Department of Defence, does include airports, fire training facilities, and every other sort of stakeholder across Australia. So there's a lot of concern and a lot of money being allocated. Where's it coming from? Well, yeah, the primary sources or the hotspots is essentially where PFAS has been used extensively or even occasionally. So generally, military bases and airports have their own on-site firefighting training or brigade facility, and obviously fire training facilities. And they're primary sources because firefighting foams often do contain PFAS. And then obviously you've got secondary sources. Now, these often sources that really aren't necessarily a source of PFAS. They don't use it, they don't make it, but they're often conduits of or receiving environments themselves for PFAS. Given that PFAS is in so many different products themselves, so it can be landfills and wastewater treatment plants. Again, they've had no responsibility in terms of producing or using PFAS, but often they're the ones sort of carrying the cup to sort of try and fix it and do something about it. And I talk about the various sources. And if you look at, say, the PFAS National Environment Management Plan, which is a bit of a very handy document, at least in Australia, around PFAS, they list about 8 pages of sources of PFAS contamination. So whether they're sectors or sources. So in summary, there are a lot of sources and sectors that have PFAS contamination issues. And this study just here provides a far more extensive review than I'll provide in a short webinar. But yeah, in short, PFAS is used in a bunch of different products and sectors. And ultimately, it often ends up in humans, whether through exposure to consumer products or the environment. It can be transferred to others, but it does absorb to a lot of our fatty tissues. The guidance and regulation, and this is a growing area, and in Australia, the key document is around the National Environment Management Plan, and they outline targets or guideline levels for drinking water and also ecological targets. The key message takeaway here is that we're talking about extremely low concentrations, not negating the potential harm associated with PFAS, but like my background is stormwater and wastewater, and we're generally talking about milligrams per litre. In this case, we're talking about a millionth of that. So 0.00023 microgram per litre, for example, is a really commonly quoted or cited or target, objective that we're often tasked to achieve to protect downstream waterways. And that, as an example, that is about 1/4 of a teaspoon of PFAS in an Olympic-sized swimming pool. So imagine a big Olympic-sized swimming pool, 1/4 of a teaspoon of PFAS. That's often the target we're tasked to achieve. And if anything, the the limits may actually get more stringent, at least in Australia. And we are seeing this overseas as well. So, for example, in the US. So again, we're talking about nanogram per litre targets, extremely low levels, recognizing that also PFAS is a very difficult pollutant to remove, and it doesn't biodegrade, which makes treatment extremely challenging. So what are the solutions? So again, if I just refer to the NEMP, they really focus a lot on, when it comes to treatment, they really focus a lot on basically separation and concentration. So there's a few different ways you can do that, whether it be adsorption, and I'll talk a lot about that in a sec, basically just absorbing PFAS to a media of some description. There's also reverse osmosis and nanofiltration, and obviously foam fractionalization and separation. But in summary, we're basically trying to take a really low concentration of PFAS and concentrate it. It's still often to a low concentration, but just basically makes that PFAS, I guess, media or PFAS contaminated media or substrate essentially a little bit easier or cheaper or low cost to manage and handle and subsequently do something with. Often the disposal method or the handling method will actually be putting it in a landfill environment. So basically concentrating that PFAS media, for example, or the contaminant, and into for example, a filter media, and then disposing that into a landfill environment, provided the concentrations are suitably low. And you can see here, for example, the generally cited concentration targets are here, but we're generally trying to get in an unlined landfill environment, for example, we want to have at least, a maximum concentration of PFOA of 50 milligram per kilogram in the media. And then there's obviously destruction technologies or processes. So this is essentially, as an example, incineration at extremely high temperatures to essentially break the carbon-fluorine bond and make it safer, I guess you'd say. I have significant concerns around doing this, but having said that, it's still recognised as a way of managing PFAS. Cool. I often get asked about nature-based treatment. And there was a lot of discussion around that for the last webinar we gave on this. But as I sort of touched on in the previous or last year's AWS webinar, there is a lot of research around nature-based treatment systems, mainly floating wetlands or constructed wetlands to remove PFAS from contaminated water. And they're showing some promise, but for me, there's a lot of concerns around relying at least solely on nature-based treatment. So you're relying on plant uptake or a little bit of more biodegradation. But long story short, I really think further research is needed around their effectiveness, particularly their long-term performance. But I still have significant concerns around, okay, if you, say, concentrate the PFAS contamination in the plants, for example, take it up. What do you do with the plants? What do you do with the soil in the nature-based treatment system? How do you remove that, mobilize it? What do you do with that plant material or the spent filter media? And also, how do you prevent these systems or nature-based systems being an ecological trap? Ecological trap being wildlife attracted to a wetland environment, unknowingly entering a PFAS contaminated area and subsequently getting sick. So that's, for me, there's some real hairs on the nature-based treatment. But having said that, it still potentially could be used in combination with other treatment systems. So again, like a treatment train approach to PFAS management or treatment. Craig, this might be Craig, this might be a good time. Just had a quick break for questions.
No, thanks for that. I would encourage everybody to try to get some of the technical questions in at the moment. I guess I wanted to just, in the meantime, turn over to Blake real quick just to get a little bit of commentary and just see if you had any questions that you had for Brad. And again, just encourage everybody in the background to keep those questions coming through the Q&A line.
Right, I've just seen there one of our audience members. There's some new guidelines that have come out.
Yeah, the drinking water guidelines. I'm just referring to the current NEMP, but this is the thing about PFAS. The targets, the guidelines are constantly evolving, and the general trend is for more and more stringent targets. So whilst I refer to some of these targets, I think it's fair to say that in the next 6 to 12 months, and it sounds like even now, the drinking water guideline targets have recently been updated as well. But as through some of the comments, they're getting tighter and tighter. So again, more and more difficult to reduce. I can see there's a bunch of questions in the chat, which as well. I'm not sure if there's any others you want to touch on.
Yeah, no, I think that's probably the main one right there is about the seniors. And I think it's just a general comment is that we, especially for those watching this YouTube recording later on, always refer to the latest guidelines. Maybe what we'll do is include some links so that you can go down into the description and see what the latest guidelines are, because we might reference something today. We might reference some limits today. You'll watch this YouTube recording a year or two down the road. It might be different. So let's just make sure we're going to give you a bunch of resources in the YouTube description and in the accompanying material as well. So thanks so much for those who have been putting some of those comments in about some of the standards and some of the updated guidelines there. So with that, again, just encourage everybody to get your questions in early so that we can hit them with the live panel discussion in just a few minutes' time. Back over to you, Brad.
Yeah, there's a question around, I'll try to touch on it a bit around, are there concerns around thermal treatment of waste and PFAS destruction as we head towards waste to energy from waste in New South Wales? Yeah, look, I'm very nervous about just burning anything and letting it expelled to the atmosphere, whether the PFAS chemicals are appropriately destroyed, amongst other things. So, and there's a question around monitoring methods. Blake, you might be best comment on sort of laboratory analyses of PFAS. How confident are you? The question is, how confident are you with current monitoring methods?
Monitoring or analyzing?
Let's go analyzing. I think that means.
Analyzing methods in the lab, I'm very confident with.
Mm-hmm.
Yeah.
If you've got lots of money.
If you've got lots of money.
That's the thing. They're super expensive tests, aren't they?
Super expensive, especially when you're doing big data sets like we have been doing for our research.
Cool. I'll keep charging. And that's a key question, because there's been a bunch, again, new guidance in New South Wales talking about how they want councils to start monitoring their landfill leachate, which again is a huge cost. Anyway, I'll keep charging. So fundamentally, Ocean Protect went about trying to develop and test some treatment system technologies to remove PFAS, and we knew we could use essentially our Stormwater technology. So, if you're not familiar with Stormwater, it's basically a cartridge filter. Water will come into typically an underground chamber, and the water will pond and basically drain radially through the cartridge. The filter media within the cartridge will basically absorb a whole bunch of pollution for a typical urban stormwater application, and then the treated water, after it goes through the central tube, will basically drain to an underdrain manifold and be discharged downstream. And so these have been used en masse, and there's about 25 plus years of R&D that have gone into essentially demonstrating them and optimizing them to maximize their performance and resilience. But we also knew we could swap out the filter media, which we typically use for typical urban stormwater applications. So we're generally trying to target the suspended solids, the nutrients, the hydrocarbons, heavy metals. But we knew we could basically develop a media or test a media at least to specifically target PFAS removal. But the Stormwater itself, like I said, it's been used en masse in a heap of different, applications, whether it be commercial, industrial, residential, etc., highways, airports, etc. It's highly modular, come in 3 different sizes. We can either put one in or thousands in, depending on the flow rate. So each cartridge has a certain flow rate. So if you need to treat more flow, you just add more cartridges. And there's a bunch of studies that basically show they work really well, at least for typical urban stormwater applications. And we've installed them 40,000 across Australia and about 300,000 overseas, including a bunch of projects at airports, which we know, again, is a PFAS hotspot generally. So, for example, in LAX, there's something like 1,650 Stormwater cartridges that no one would even know about unless they pop the lid, but they're going a long way to help protect downstream waterways from some of the pollution washing off the airport. Similar in Sacramento, similar underground chamber installed with a bunch of storm filters to target typical pollution, not specifically PFAS. But yeah, we've applied these en masse, but we knew we wanted to develop a filter media specifically for PFAS removal. So enter Blake Ellingham with his fancy research. Did you want to talk to this, Blake?
Yes, Brad, give me 1 second. I'm just replying to one of the comments in the chat. Thanks, Brad. When we began developing a technology to remove PFAS from stormwater about 5 years ago now, I can't believe it's been that long. It was the topic of my university thesis, and we started trials at a lab scale, testing about 6 different medias for performance, flow rate, and then comparing that to the price, with the ultimate goal of developing a passive system that was also affordable with a small footprint. We selected one of the medias and moved that into a controlled field scale study. Yep, you've got the slides, Brad. Yep. Although the field scale study was not completely passive, we wanted to be able to control the influent concentrations and the amount of water that we were treating at the specific flow rate. For the first test, the primary objective was seeing how the technology would perform in a real-world study. In a lab, it's very controlled. So we wanted to see how the field would affect the technology. We treated over 300,000 liters of water over a few weeks, doing grab samples every 200 bed volumes. You hear the term bed volume quite a bit. It's essentially one bed volume is essentially the volume of media within our filter, which is about 70 liters. The results were analysed with my university professor at the University of New South Wales. We're achieving above 80% removals for most of the test, up to around 4,000 bed volumes. For PFAS and PFHSX, we were trying to achieve below the previous Australian drinking water guidelines. We didn't achieve that for this test. And for PFOA, the influent concentrations were already below that limit.
Yeah, so just to explain the graph as well. So we've got on this blue line up here, we've got essentially percent reduction. On the green aqua line is the influent, and the dark blue is the effluent, and the red line is the target. So concentrations on this y-axis here, and the secondary y-axis over here is percentage reduction. So we generally see, high reductions up to a certain, period, and after which we see typically often a deterioration in performance. So essentially, this period from start to about here would be what we consider the peak performance period, where we're sort of it's basically the lifespan of the cartridge, and after this time you might look to replace the cartridge, because essentially the absorptive capacity of the filter media has reached a limit, and we're seeing a deterioration in performance. Then you start with field study 2, Blake.
Yeah, so field scale study 1 concluded with the car occluding, and we really wanted to extend that peak performance period. So we introduced a pre-treatment with the jellyfish, which is a membrane filter with 20 micron pores. And we also introduced much higher influent concentrations of the sum of PFAS. We used auto samplers this time, taking samples every 25 minutes, and we collected a lot more samples during this second field study.
And for people who aren't familiar with the jellyfish, it really was just used for pre-treatment itself. So it's similar to the storm filter, and that's an underground asset, but we don't use filter media as such. We use actually what we call a membrane. So it's really, really small apertures and basically stormwater will come in, or water will come in and basically be forced through the membrane itself. And obviously during that process, a whole bunch of pollution will be removed. But the key thing to take away here is that this membrane cartridge doesn't really do much in terms of PFAS removal. What it does in the treatment train combination with the downstream PFAS removal systems is that it's really aiming to remove organics and solids and other pollutants that will otherwise blind or compete with the PFAS absorptive sites in the downstream device. So it's really just pre-treatment to remove solids and organics. This is a pretty stock standard technology, again, using a bunch of different land use types, different configurations. We can use one or many cartridges in combination. A lot of data that shows they work really well, and we've installed these on many sites across Australia. So it's a pretty tried and proven technology. And if you look at the field study 2022 results, for example, for some of PFAS, you can see the blue line here is percentage reduction. But you can see the green line here, or the aqua line, is water coming into the jellyfish, and the orange is the water concentration coming out of the jellyfish. So you can see here, even with a really, really small aperture membrane cartridge, it actually does pretty much nothing in terms of PFAS removal, which is what we'd expect. Again, this shows that how difficult it is to remove PFAS. The cartridge, the PFAS filter cartridge is really good at removing PFAS, but the membrane, the jellyfish membrane system doesn't really do much, but it does extend the life of the downstream PFAS filter. So again, we're seeing after it goes through the jellyfish, we're seeing a substantial reduction in PFAS concentrations after the PFAS filter. And this is pretty consistent for a bunch of analytes. Sorry, Blake, I don't want to steal your thunder.
That's all right, Brad. So with the second field study trial, we're able to extend the peak performance period. Although you can see the total bed volumes was less, the influent concentrations coming in were about 40 to 50 times higher than the first field study. The key in these result summaries is the total load removal of the sum of PFAS. You can see there about 340,000 micrograms. In comparison to the second field study, we were able to extend that to nearly 2 million micrograms of total PFAS removed just by adding the pre-treatment and preventing that Radial Flow cartridge from occluding.
And a common question we also always get asked is how long until you have to replace the filter media or the cartridge itself. It really depends on the loadings, so flow and concentration. So if we've got a really high PFAS contaminated site with high loads of PFAS, you'd expect the cartridge to need replacing more frequently than you would otherwise if it was really, really low concentration or low flows. But generally, for most of the projects we're looking at, it's generally around about a year for the first sort of bank of what we call bank of cartridges. The results, when I was charged through that study and results, but they're all published in the Australian Water e-journal, which is publicly available now as well. So if you're keen to find out more, you can dive into that. Then Blake did another study. Blake, you want to talk to this?
Yeah. So moving on to the third field study, it was really about determining how low of concentrations could we achieve. Where the previous studies looked at sort of the average and then the high end, the industry was sort of moving to these lower and lower targets. So we wanted to determine sort of what was the lowest possible concentrations we could achieve. We did this by modifying the second field study and recirculating the water back through and adding a second Radial Flow cartridge to the back end of the apparatus.
Yeah. It's hard to interpret this figure, I know,
Yeah,
but we're talking about such low concentrations. It's really hard. Like we looked at logarithmic scales and all that sort of stuff. The key message, I know it's hard to take away from this, is even at really low concentrations, like really, really, really low influent concentrations, we're still achieving significant reductions in PFAS analytes. So we are seeing a slight reduction in total percentage removal at lower concentrations, but we're still seeing significant, greater than 50% reductions in PFAS concentrations. So if we needed to achieve really progressively lower and lower concentrations, what we're seeing for a lot of our sites, we just need to run them through another bank of cartridges to achieve low.
Even that one, just go back a slide. That one there that's got about 5% removal of PFAS removal. I think that's because we were going from something like 11 nanograms down to like 10.5 or something like that. It was super low concentrations, and we were still getting removals there.
Yep. Yeah, and I know you want to comment on this one, this PFAS slide, Blake.
Yeah, so with the field study 3, you can see most of the blue dots there. They're down in that bottom left hand corner. And we're still achieving super high removal rates. Around 50% sort of as we got down to about 50 nanograms, thereabouts. Keep in mind that we had been recirculating the water as well. So there was the potential for some contamination in the pipe network from when higher concentrations were coming through. Our lowest
so the lowest
result
you go.
was the 9 nanograms, which is above the new drinking water guidelines that were put in the chat before of 8 nanograms, and above the 99% speciation protection for PFAS of 0.0023 micrograms per litre.
Yeah, so we think that residual concentration is due to residual PFAS contamination in the recirculated sort of system or pipework, for example. So hence we're doing another field study, aren't we, Blake? But before we talk about that, the key, I guess, summary for the 3 field studies we've done to date is that we're seeing really, really high PFAS removal rates, generally lower removal rates at lower influent concentrations. And we did see that was it some of PFAS was a little bit above the 99% ecosystem health target of 0.00023, and we think that might be due to contamination just by the fact that we're recirculating PFAS contaminated waters through the treatment system.
And sorry, bro, just before you move on there, we go back one slide. We repeated this test twice, and we've seen very similar patterns as as PFAS was removed, and we achieved that 0.009 both times.
But again, the study results who have presented to date are all in that publicly available report you can see on the right there under the website link there. Leading to study 4, Blake.
Yes, so this will be later on this year. We're essentially going to eliminate that potential for the PFAS to be residually contaminated in the pipework by adding in multiple banks, up to 7 Radial Flow cartridges put into series, and that will remove any contamination risk.
Cool. Likely applications. So we've been approached by a bunch of potential clients and potential project sites, but without giving any names away, the likely applications for this technology is the likes of military bases, airports, fire training facilities. Having said that, most of our inquiries have been done from other project types, whether it be linear infrastructure projects like road and highway projects. There's a question in the chat about groundwater. Yeah, so this the technology, the storm filter technology, is a stormwater treatment technology, and we thought the Rad Flow technology, which is the one the term we use for our PFAS filter that uses the storm filter technology, we thought most of the inquiries would be for stormwater. But yeah, I'd say 99% of our inquiries are actually for groundwater treatment projects. So when you talk about groundwater, it's really just a case of, instead of just letting water passively flow through the treatment system, we're pumping up to a certain level and letting the water passively drain through the system. But it does need basically a pump and treat option. There's a bunch of considerations. It's not all sunshine unicorns. There's a bunch of things that we need to consider when it comes to removing PFAS from contaminated waters. Like I've already touched on the concentration, loads and types, the solids and organics that can otherwise compete with the PFAS absorptive sites, obviously flow rates, etc. Hydraulics, the targets. This is a moving beast. We've touched on the guideline targets already, and they are evolving and changing. Sometimes it's a case of what's actually practical to achieve. And in terms of the operation and maintenance, that's a key thing. Like, these systems need to be, the PFAS isn't magically removed. It's retained within the cartridge, and then you've got to look to manage the spent filter media. What we do for the Rad Flow cartridges is we actually take the spent filter media, take a sample, assess it to make sure it's the concentration is within certain limits, suitable for landfill disposal. But we keep the filter media within the cartridge itself, and then we'd look to put it into another container for transport, basically minimizing any risk of sort of contamination, etc. So it's basically within a container, and then we put it into another container, and then typically would place it in a suitable landfill facility. You could obviously look to do the destruction or incineration, but generally we're looking at the landfill management option, the landfill end of life disposal option, recognizing that it is in basically two containers, so the risk of leaching or movement of PFAS in the decades to come would be extremely low. But like I said, the cartridge itself, the what we call the Rad Flow cartridge, is highly modular. You can either look to put in one cartridge to treat a certain flow rate. And for example, there's the 690 cartridge would have a treatment flow rate of 0.69 liters per second. Or you can look at putting in literally thousands of cartridges, depending on the size of the volume of water you're needing to be treating. Key advantages, and this is generally from our clients, and we could talk about the turnkey solution, the fact that we can do design, install, management, etc. It's passive, it's underground, so super handy for say airport sites. We can do the multiple pass systems, but probably the key thing is the cost. The feedback from our clients is that we're just substantially less expensive than alternative currently available technologies. So generally the feedback is we're 5 to 10 times less expensive in terms of CapEx and also significantly less expensive when it comes to OpEx. So I think a key reason for that is the original storm filter technology. There's just so much R&D that's gone into that over the last 25 plus years to maximize the resilience and performance of it. And then in parallel to that, more recently, developing a suitable filter media blend to remove PFAS. And I think those two things have really provided essentially an extremely attractive technology option for treatment for PFAS contaminated waters. As an example, this is an example project, or at least the design of an example project. So this is a groundwater project. I can't say where or for who, but it's basically treating a lot of water, 1 million gallons a day for the people in the US, constantly. So whether it might be a groundwater project or similar, basically every 8 hours we pump the contaminated water through one stream, and then that stream has two banks of cartridges. So it gets treated by the first bank, 44 liters a second, and then for polishing, it goes to the second bank of filters. And after 8 hours, you go to the second stream, and after that 8 hours again, you go to the third stream, and after a 24-hour period, you go back to the first stream. Basically, gives each stream a bit of a chance to recover or dry out a little bit to enhance its performance. That's another sort of example diagram, and that's sort of kind of what it might look like underground. Look, we've given a crash course in this technology, though. If you want to find out more, we've got a website, obviously. You can see the link at the bottom there. And we're happy to, I know there's a bunch of questions coming through, but if we don't get to all of them today, feel free to reach out to myself or Blake or our illustrious leader, Michael Kenneth Wicks, who will be joining us for the Q&A. I think he already has. But I'm happy to leave you in the tender care of Craig to manage your questions as well.
Yeah, thanks. So we obviously it's a problem. PFAS is a buzzword that you hear about all the time. Kicking off our 2026 webinars this year. We don't want to leave you with a bleak outlook on just presenting a problem. We're presenting solutions as well. So it's great to see that there's capital investment going into solving this problem, and that there are some brilliant minds going into research and development to try to figure out the ways to handle this. So there are some very technical questions coming through. Let's because we've already heard from Blake and Brad, let's put Michael on the spot. And Michael, if you can see that list of questions, rather than me picking one out for you to answer, I'll just leave it to you to pick the lowest hanging fruit, the thing that's going to probably hit the most audience members. If there's something that you wanted to address from the Q&A that's come in so far, things you've addressed already, let's turn it over to you to hit some of those questions.
Look, thanks, Craig. Look, I think a lot of the questions revolve around what do we do with media, and effectively we just send the media to landfill. So it's all about landfill at this stage. We're currently in the throes in the R&D department working out what we actually do with the canisters. We believe that the canisters themselves can be reused. So we're working on that at the moment, just tipping the media. So that's probably where the majority of questions come from. And also, typical questions around longevity and expense. Look, we use inside the filter a modified activated carbon. We've also, and it's not just the storm filter, we've changed some parts out there as well. So there was probably about 2 years worth of R&D just tinkering with this system in the lab to sort of get it right, to get the unison between the filter and the media, together with the expected performance as far as percent removals down to certain concentrations, but also maximizing the longevity or the sorptive capacity of the media. So a lot of the questions around longevity, We can tell you what the longevity is. And if you think about the treatment train, we've used a membrane filter upstream of a modified GAC filter to effectively remove PFAS. So for us, if we have good background data on the site, i.e. we know what the concentrations are within a range, we can then give you a fairly accurate estimate on what the longevity of the system is. And we've dealt with all those pre-treatment concerns as well with the membrane filter. And that's why we drop that in on later parts of the trial studies, because we were finding that we were using a fine media, we were getting some competing contaminants, we were getting some basically some hydraulic issues with the filter. So when we put the membrane on, we cut out all the competing contaminants. It was great pre-treatment, and then we just allowed the GAC media filter or the storm filter to basically do its job at the end of the day. So a lot of questions around that, around longevity. It really depends on your site, but we do know what the sorptive capacities are, and the sorptive capacity of our media does exceed the sorptive capacity of the industry.
Oh, just lost audio, Michael. I think you were saying the absorptive capacity of our filter media exceeds the absorptive capacity of other on the market.
Yeah, typical GAC. Yeah, when we first looked at this, Brad, we found that we had like 2x on the closest GAC industry standard as far as sorptive capacity goes. So we're sort of we know what each cartridge can get, but it was significantly more. We know GAC's been used for PFAS for quite some time. It's been used for a range of contaminants in wastewater and stormwater. We all get that. But the proprietary product that we got modified and then purpose fitted to the cartridge certainly was, from what we've seen from the data, a real winner.
Excellent. Yeah, thanks for all those responses. Tons of questions coming through. It did take a little while to heat up, but wow, there's a lot coming through. I'm not sure if we'll be able to get to all of them. So if you have a question, if you could please just have a look through, see if somebody's already asked something similar and upvote those. We will try to hit the most upvoted questions first. Looks like, a lot of people are saying, well, hang on a second, if these cartridges are not reusable and end up in landfill, and is that moving the problem downstream? Maybe just projecting out, Blake, thinking about your research, 20 years from now, do you see, reusable cartridges coming into play? Are these going to keep going into landfills? And does that just move the problem downstream?
Absolutely, Craig. One of the key things with this storm filter in comparison to other vessels that are used in the industry for treatment of PFAS is the cost of the storm filter as well. Not only that, with the media, is a lot cheaper than your traditional pressure vessels that are used, and they use a lot less plastic too. We'll be looking as well to potentially manufacture those cartridges out of a recycled plastic, so there's less impact on the environment in that way, with the ultimate goal being to reuse those cartridges. And that's mainly from an operation and maintenance manual perspective. Safety for our team is of critical importance.
Yeah. I'm looking at the questions now. I'd say 90% of them are associated with longevity and lifespan. So Michael's addressed that really well. There's a couple of questions around costs. So do the costs include transport and disposal? Yeah, so one thing that we do that might be a bit different to others is that we do the whole turnkey approach. So design, install, and can do management of the spent cartridges as well. So it definitely includes those costs. There's a question around, can we use ecology to concentrate PFAS given it accumulates in the food chain? I touched on nature-based systems and particularly around wetlands and floating wetlands. I'm guessing Emma's question is in relation to maybe we could, it absorbs the fatty tissue. So could we just get a whole bunch of fish in there and I don't know, have them swim around and accumulate the PFAS and, dispose of the fish. The key drama is, okay, then what do you do with the fish? I think whether it be fish or oysters or, I don't know, platypus. Obviously, there's an ethical question around that, but I think I'd prefer to absorb PFAS to, filter media, activated carbon blend, than ecology. I'm not sure if that's an HE question, Emma, but please correct me if I'm wrong.
Yeah. Well, if you have a look at these at the questions coming through, if we don't get to all of these, what we'll do, have a look in the YouTube description if you're watching this later on. But what we're going to try and do is compile some of these and put some answers together for you in writing for anything that we don't get to, or any last minute questions coming in. So don't fret if we haven't got to your question. We'll try to address that in text later on. So yeah, just going back around the room again. Pick a question or two to answer, or those that you've already answered, and maybe just restate those.
David Buck asked an interesting question, and Buck is actually a pretty famous name in the PFAS research circle. So I don't think it's the same guy, but great name anyway. He asks, is say that PFAS is not present in the manufacture of polyethylene water piping in Australia, is that guaranteed, or are we expecting the next asbestos like health concerns? Plumbers and suppliers believe there is no PFAS in these piping systems and sell them as such. Are we certain there is no cover-up? I love a good conspiracy theory, Gray. Look, I'm not certain, but one of the key dramas with PFAS, and I touched on this at the start, is that there's just so many different types of PFAS. And we only analyze for a relatively small number. Like when Blake sends his samples off to a lab and gets them analyzed. 28 PFAS types. And that alone, how much the single sample cost to analyze, Blake? It's
about $250 to $300.
Okay, that's a pot. That's per sample. So for 28 analytes, recognizing there's about 14,000 or thereabouts, probably more PFAS chemicals, we physically can't analyze for all of them. And often when one PFAS type gets banned, the manufacturers might make another one, and we physically can't test for it. So the certain manufacturers might say, yeah, there's no PFAS, for example, in whatever the product might be. There's no guarantee, though, that they haven't replaced it with another potentially worse PFAS type of chemical. So don't want to ruin everyone's day, but it's
yeah. I think, look, we're not confident there is a conspiracy or not. We just don't know. I think that's what the science says at the moment. So we can all put our tinfoil hats away at the moment. But, I think there's a lot we don't know, given that there's so many chemicals and there's so many little chemicals that we actually analyze for in the lab. So
there's a couple of questions around end of life, and it's a really good. I'll give you an example. Max asks, okay, the spent cartridges are being used as being disposed to landfill. Given the increasing challenges associated with landfill leachate, is there any consideration being given to the long-term management or alternative end-of-life pathways for these highly PFAS-laden materials? Yeah, look, it's a great question. We don't want to kick the can down the road, and we're obviously very conscious of what happens downstream. Hence, our company is Ocean Protect. We're all about protecting our oceans. But I still maintain we're taking PFAS contamination in surface or groundwaters, concentrating into a filter media, so highly absorbent filter media. That's already in a container, a cartridge, and then the disposal method is to carefully handle that and place it in another extremely well-sealed impermeable container, and then transporting that to an appropriate landfill facility. So is that an absolute ironclad guarantee that PFAS isn't going to make its way into the environment 1,000 years' time? It's not, but it's certainly probably the best we can do, or a very good outcome for the time being. Michael or Blake, do you want to comment on that at all?
Look, yeah, what we can probably say, Brad, is that we will have a solution for recycling the cartridges in the next 12 months. We're pretty confident where we sit with that. We've already looked at some, different strategies around that. Like you see pressure vessels that get washed all the time. They get reused and filled with media and away you go again. So we're confident we can reuse the cartridge vessel itself, just tip the media. So we will be able to reduce the waste. But Brad's right. It's probably the best, safest step at the moment. But yes, we will be reducing our waste in the future. There's no doubt about that. And that's a key sort of area of research for us internally.
Yeah, and I mean, looking at the map of the... Oh, go ahead. Sorry, Blake.
So just to touch on that, I think with some of the confusion might be coming in comparison to other technologies, our primary focus is a passive solution. So this won't be primarily being pump and treat. So a lot of these systems will be underground in confined spaces where the guys will physically have to go and retrieve these vessels. So we don't necessarily want them using vacuum excavations to remove the media and exposing it, or aerating the media, aerosolizing the media while they're down underground in a confined space. I think that's the major difference compared to the industry standard and norm at the moment.
Yeah. Well, I would think when you look at the map at the beginning of this webinar, we've got a global audience, hundreds of people attending this webinar, potentially thousands of people looking at some of our previous webinars on the topic, watching this later on, and potentially recognizing the severity of this problem. All of that collective willpower, that collective mind power, brain power, innovation. I mean, think about what we could be presenting, like Michael said, 12 months from now, there might be a new solution that you're coming up with. This is one group. What about everybody else? So, I think we can do great things as an industry. And I'm hoping that new technologies will keep emerging to help solve some of these problems. Ocean Protect, our sponsor today, we're not placing these things out in the ocean. It protects the ocean when we protect these things upstream. So a lot of these solutions that you see are not sitting in the ocean. These are sitting upstream. And so even though our sponsor is called Ocean Protect, what we're doing is protecting those resources by getting to the source further upstream. Keep going with that, and maybe even the production of these things can be reduced over time, and we're dealing with the sources, not the symptoms of the problem that we're dealing with. So thanks so much. Our time is just about up, but we'll go around the room one more time and have everybody just give some closing remarks, take home messages, and then we'll introduce again to you this course that's coming up, where you'll learn a little bit more about some of these issues, the water quality issues, but also bioretention and some other topics like that. So back around through the room in the order that we did in the beginning. We'll do Brad and Blake, and then Michael, give us your take-home comments for today.
Look, I think the key message for me is we're always learning. This is a really fast-moving space, but it is a chemical that I think we really need to be concerned about. The regulations are changing, the treatment systems are evolving. But look, if you've got a PFAS concern now, today, just reach out to us. We're happy to talk about this till the cows come home, and we don't charge for our time. We might, if we can't help you out, we'll certainly refer you to someone who actually can. But long story short, just reach out if you've got a query around PFAS.
Great. Blake, take-home messages from you.
I'm excited to see where the research over the next sort of year takes us, and hopefully we're going to achieve those 99% speciation limits of the 00023. We'll keep you guys posted.
Excellent. Michael, bring it home for us.
Look, yeah, I think it's just probably echo Brad's comments. Really, if you have a PFAS concern or inquiry, especially related to stormwater or some pump and treat systems, give us a call. We're not just here in Sydney, Brisbane, Melbourne. We can also apply solutions in North America. So through our partners there. So look, just drop us a line, get in touch. As Brad said, obligation free, and hopefully we can help you with the PFAS problem.
Sounds good. And, Brad, you mentioned Mark Ruffalo playing one of the characters. I guess I'd be curious. You don't have to answer right now, but who's going to play you, when they do make a movie about the PFAS problem later?
Ray, look, I'll be embarrassing and just play myself. It's a critical acclaim, Craig. Absolute critical acclaim.
No shame. No shame.
No, and definitely I'll make a plug for Brad's podcast, a very popular podcast. Do subscribe to that one. And we'll put the links to some of the previous courses. A lot of free stuff out there. There are some paid courses coming up, but there are tons of free resources that Ocean Protective put out. Brad does interviews with people around the world, people who are activists, people who are addressing some of the water pollution problems all around the world. We've had Ocean Protect on with us when we've talked to Captain Moore and others who have been out there on these sailing vessels, just going out and tackling these problems head on. Do subscribe and have a listen to some of the awesome guests that Brad has interviewed on some of those podcasts. With that, get involved in these upcoming training courses, which you see on the screen. Stormwater Treatment 101. We've got a little bit of introductory material that you can look at on the webinars, but this will be interactive with the experts. Come have a look at, how to solve some of these problems upstream before they get into our ocean and cause us some problems downstream. You've got a 10% discount code that you can see right there. So thanks for joining us today. To all of our attendees, thanks to the presenters for coming on and and volunteering your time to our sponsor, Ocean Protect. Again, you'll get this recording link for everybody who attended. You'll get your professional development certificate. So again, if you're looking for that for some of your engineering licenses and things like that, do attend some of our courses and webinars going forward. You will get that certificate. And do not leave us today without letting us know what you want to see of. This kicks off our 2026 webinar series. There's a lot more to come. Some of the things that we have planned, we do have some open spots in a few months' time. So when you get us your feedback on what you want to see more of, we will try to get you the best guests and the best information and the experts that are going to help further the industry in your area of the world. So thanks for that. We'll see you again next time with the Australian Water School. Bye-bye.